Right. Good afternoon, ladies and gentlemen. Thank you all for attending APulsar's Insight 4.0 webinar series. I hope everyone had an amazing lunch. My name is Wei Yao, and I'll be your panelist this session. For those who joined our previous webinar, welcome back to another Insight 4.0 episode. The title of today's webinar is MOXA Cybersecurity Solution. We'll get into the details shortly. But first, allow me to provide a brief rundown of the webinar structure. We'll take a quick minute to get to know the organizers, then move on to the presentations. Today, we'll have the main topic delivered by Sever Sudakov and a deep dive into the products shared by David Yao from MOXA. That will be followed by a live demonstration of the IPS unit in action. Lastly, we'll have our questions and answers segment. Full disclosure, Sever's presentation is pre-recorded. However, he will be with us in the webinar for the Q&A session. You may leave your questions in the Q&A section below and they will be answered. If you have questions regarding specific solution or situation, APulsar welcomes you to get in contact directly, so we may provide you with the best answer. So today's Insight 4.0 event is put together by APulsar and MOXA. At APulsar Technologies, our main role is attending two mission-critical areas: industrial networking and uninterrupted power, offering solutions to ensure integrity of customers' industrial networks and keep operations running with uninterrupted power. APulsar don't just provide hardware, we have the technical engineers to assist customers with technical proposals, network designs, installations, configurations, and after-sales services. We are pleased to be channel partners with industry leaders like MOXA and Delta. MOXA is the leading provider of industrial networking, computing, and automation solutions. With over 30 years of experience, they are the world's #1 in serial devices. They have successfully connected more than 60 million devices worldwide, enabling their customers with automation and remote data gathering. Globally, MOXA has 13 offices in 4 continents and over 70 countries covered by distribution channels. Now to introduce our speaker. Today's introduction to cybersecurity will be delivered by Sever Sudakov, a solution architect with MOXA Asia Pacific and Taiwan. With more than 10 years in industrial automation, he's now a Cisco certified network professional in routing and switching infrastructure, as well as ISA IEC 62443 cybersecurity fundamentals specialist. Today, Sever will share a thorough introduction into cybersecurity for operational technology and discuss the benefits and difficulties of some of the countermeasure solutions.
Hello, everyone. Thanks for joining today's webinar. My name is Sever Sudakov. I'm a solution architect for MOXA's Asia Pacific and Taiwan regions. So before we get started, I wanted to share a couple of important notes with you. If you have any questions during the webinar, please use the questions panel to submit them, and our panelists will address your inquiries. Also, at the end of the webinar, you will get a short survey, and we would really appreciate it if you can take a moment to answer a few brief questions and let us know how you found today's session. So with that said, I think we are ready to start. The webinar is titled Cybersecurity Below Industrial DMZ. And hopefully it's a start of webinar series about OT cybersecurity. So you can consider this as an introduction presentation for OT people about solutions that they may need to implement and work with. Here is the agenda for today's session. I will quickly explain the context of OT cybersecurity, and then we will talk about most common solutions in the market, discuss key features, the pros and cons, and finally, I'll briefly tell you how MOXA relates to this topic. First, I would like to explain why I named this webinar Cybersecurity Below Industrial DMZ. Back in the days, OT systems, they were isolated from IT systems and mainly used highly proprietary components. So the cybersecurity risk was minimal. Later, with the advancement of technologies and higher adoption of common IT tools in OT environments, the air gap disappeared. To manage cybersecurity risks related to convergence of these two worlds of IT and OT, people usually install a firewall, and if they follow best practices, they create an industrial DMZ between the OT and IT networks. In simple terms, it is a dedicated area that acts like a buffer. IDMZ devices are allowed to collect information from OT applications and then share it with IT services. No direct communication between OT and IT is allowed. This is a best practice for connecting OT to IT, since it minimizes the risk related to direct connection of the two. In my experience, when a cybersecurity enhancement project is led by IT people, forming an IDMZ is where OT cybersecurity begins, and unfortunately, in many cases, it also ends there. The reason is simple. OT environments are too alien for IT folks, so they don't fully understand what the risks are and how to deal with OT equipment. Moreover, OT personnel usually don't want to make any changes to their systems, especially if they don't understand how newly introduced solutions operate. Nevertheless, that understanding gap has to be fixed because just having an IDMZ is not enough anymore. There are actually many methods to infiltrate a network that wouldn't require an attacker to go through an IDMZ. Following the defense in-depth concept, we don't want to rely on IDMZ as the only protective measure for OT. Here are some attack vectors on OT. Removable media. This is an obvious one. We carry them around, plug into different computers to import, export projects, get logs, and so on. It could be infected elsewhere, then brought into an OT environment. Another common problem is unauthorized connections by in-house engineers or contractors. They may directly connect their laptop into an OT network to perform maintenance or simply to charge their phone through USB port of an OT workstation. Since that external equipment is not trusted, it could carry some malicious software. Also, there are many cases when engineers leave remote access to OT equipment to perform tasks without visiting the site. That could be a cellular gateway or even a laptop with remote desktop service. The supply chain itself could be compromised. Device firmware could be replaced in transition, for example. In other words, there are plenty of reasons why we should care about cybersecurity inside OT and not relying on IDMZ only. Can proper levels of cybersecurity be established quickly? Unfortunately not. It is a long journey, and moreover, it is not just a one-time project. It is a continuous process that requires continuous efforts. To make this process easier to understand, we can refer to this maturity model. It has several incremental levels associated with typical countermeasures for each level. You can see how as maturity builds up from left to right, the requirements of the most precious resources of the human workforce and its expertise also builds up. You can't simply buy the most fancy solution and make it work without a dedicated OT cybersecurity team. Today, we will mainly focus on the first 3 levels and solutions for them, because this is where you want to start your cybersecurity journey, and this is where you find OT-specific tools that have to be installed in the field, which may directly impact operations. Standards are good reference points when you don't know where to start, and cybersecurity is not an exception. So it has its own standards. The most famous one and probably most comprehensive for general OT applications is ISA IEC 62443. You may have heard about this standard from both vendors and asset owners because it defines how cybersecurity should be implemented in OT. What is its life cycle? What are the requirements for all parties, and many more. However, some industries such as power, marine, as well as oil and gas require a tailored approach, so there are additional industry-specific guidelines. And the last thing I want to mention before we jump into solutions overview is types of countermeasures. There are 2 big categories, built-in and bolt-on. Guess which one is better? Of course, built-in. Built-in means that developers of the system took serious consideration of cybersecurity and implemented embedded protection. Here are several examples of built-in security mentioned in the standards. ISA IEC 62443-4-2 states that to achieve a certain level of security, a device should have a hardware root of trust that can be used to verify firmware and ensure configuration integrity. Device functionality should include role-based access with capabilities of centralized account management. Another example is from IEC 62351, which says that messages between ID and SCADA should be encrypted, and messages on a process level should be digitally signed. So the built-in approach reduces risk on a very fundamental system component level. But ask yourself, how many devices in the field have a good level of built-in security? Probably very few. We still have many legacy devices that weren't designed with cybersecurity in mind, and I don't think we can afford to replace them all anytime soon. That's why we have to rely on bolt-on or additional cybersecurity measures. Those are tools that are installed to enhance the cybersecurity of existing system. You heard a lot about firewalls, antivirus software, intrusion detection systems. They are all examples of bolt-on security controls. When you are picking a product for your system, in case of built-in security, it's pretty straightforward. Just ask your vendor for standard compliance, or ask them to provide you with a compliance matrix that allows you to meet your desired set of requirements. And since it is a native device feature, everything should work smoothly. For bolt-on solutions, it's more difficult to make an optimal choice. That's why for the rest of the presentation, I will talk more about which bolt-on solutions are common for OT and what things you have to consider when you are choosing one. So let's dive into it. I will use this simplified OT architecture to show you where cybersecurity countermeasures can be installed. Right now, there is no protection, and we are going to add it layer by layer. To keep it simple, I have divided countermeasures into 4 groups. First, and probably the most obvious thing, is that we need to protect our hosts or devices, because in most attacks, they are the final targets. The network forms the backbone of the system that enables communication between devices. Therefore, access to the network has to be restricted. in order to prevent an attacker from breaching devices and executing various network-based attacks. Since networks might be large scale and connect multiple systems, it is important to manage this shared infrastructure properly. We can restrict data flows through network segmentation and establish secure communication channels. And finally, it's a good idea to enable security related to visibility and detect threats to be able to react properly and prevent attacks, or at least minimize the impact. Let's take a look at each category in more details, starting with device security. We protect our personal and office computers with antivirus software, or if antivirus software is combined with additional features, we call it endpoint protection. Modern OT computers are very similar to personal computers, so the same approach can be used here. The general idea is very simple. We try to lock operation of the computer to a predefined list of actions. So anything outside of that list would be rejected, or at minimum, it would require additional authorization. I actually think this approach works even better for OT computers, since their functions are very limited to supporting OT system operations. We don't install random pieces of software or browse the internet on SCADA machines, right? So what exactly can we lock down? Industrial computers have ports to connect peripheral devices such as USB, and those ports could be attack vectors, remember? Endpoint protection can lock physical ports and allow it to be used only for limited devices that have passed authentication, or if their device ID is listed as approved. To protect from network-related attacks, endpoint protection usually provides a host-based firewall that can lock communications to only necessary connections. Also, configuration or system settings can be locked, like IP settings or wireless network settings. What we don't want to see on an industrial PC is execution of unnecessary or even harmful applications. To prevent that, endpoint protection can lock services and programs to a predefined list again. This will help with some malware types and unauthorized applications executed by employees. Another good idea is to lock critical files from changes. Those files could be SCADA projects or PLC configurations. And lastly, there is still a need for antivirus functionality because malware can mimic legitimate processes, or if it's a virus, it can infect system executables. So locking by itself might not be sufficient, and regular scanning needs to be performed. Referring to our diagram, we can apply endpoint protection to OT computers, like engineer workstations, SCADA servers, and clients, and other application servers. The question is, can we directly apply the same endpoint protection that we use on our laptop in IT environment? I think there are two problems here. First, we still have a lot of Windows 7 and even Windows XP computers in OT. So operating system may not be supported by vendor, and IT-grade and protection solutions, they do not support legacy systems as well. So that's why OT-grade endpoint protection would include the compatibility with a wide range of legacy systems like Windows XP, NT, 2003, and some versions of Linux. The second issue with applying IT-based solutions is their impact on the performance of a computer. I still remember times when I had to take a coffee break while antivirus performed scanning of my laptop because it became much slower than usual. So when OT computer is running a critical process control task, we cannot accept that kind of performance downgrade and slow response time. So another feature of OT-grade endpoint protection should be a minimal footprint. Some vendors go beyond stating memory and CPU consumption in their datasheet, and they actually test their product with major SCADA brands to verify compatibility and ensure that there is no impact to performance. I would say that endpoint protection is a good bolt-on security control. However, we need to carefully consider the side effects on the system. Also, sometimes due to the warranty terms of system supplier, it is prohibited to install such software. So we have to choose other ways of protecting. And last, if the endpoint protection has an anti-malware component, we also need to consider how to deliver signature updates, whether we place an update server in the DMZ or if we deliver updates manually on USB stick or by any other method. So if for some reason we can't install endpoint protection on OT computer, or if we want to protect a device with proprietary architecture, what can we do? That kind of OT device for us is essentially a black box. We may not know how it operates, but unfortunately, we may find that someone else already discovered its security issues and published security advisories. If we can't patch the device, if we can't install additional protection inside, the only way is to place protection outside on the network link. Usually that would be inline protection or an intrusion prevention system. Functions that can be used to protect would include communication whitelisting, such as firewall, and probably with industrial protocol awareness. And another function is virtual patching. This is used instead of applying a patch on a device. We can drop packets related to exploitation of a known vulnerability instead. It's almost like an antivirus protection applied on packets instead of files. It is also based on signatures, so network-based anti-malware, it kind of comes as a bonus. We can place an IPS in front of a PLC, DCS, and HMI devices on our diagram. That's because usually they have a proprietary architecture. I mentioned that an OT-grade IPS should have deep packet inspection that supports industrial protocols. We should be able to specify whitelisting on a deeper level, not just allowing entire application protocols such as Modbus, Profinet, or Ethernet IP. But we should be able to specify the particular commands, device IDs, registers that are allowed. Regarding virtual patching, a vendor should provide signatures for OT-related vulnerabilities, not just general-purpose IT threat signatures. The benefits of such IPS is that it can be applied to almost any asset without reconfiguring the system. So it's ideal for brownfield projects. As usual, we need to carefully consider the impact and be aware that any additional component on your network will inevitably increase latency. For IPS and firewalls that both use software-based packet processing, latency could be a real issue. So this kind of protection is usually not applicable to time-sensitive devices and protocols. And speaking of protocols, this is still a relatively new industry, and a single vendor may not be able to provide DPI for all the protocols you need. And it is actually often that the protocol support may actually be the major decision factor. As with any active protection measure, there is a chance of blocking legitimate traffic, especially when it comes to signature-based methods. Therefore, extensive testing has to be done before applying any solutions in a production environment. As with endpoint protection, we also may need to arrange a delivery of signature updates to perform virtual patching of newly discovered vulnerabilities. So again, that would require updating infrastructure and procedures. And finally, once we put a device between an asset and the network, we need to make sure that it will not become a single point of failure. Such devices should have redundant power, or even better, to have a bypass mechanism that would allow communication if there is a protection failure. So these two types of bolt-on cybersecurity solutions are the most common for device security. We covered endpoint protection software and IPS. Now, let's move to network protection. There are two essential functions in managed Ethernet switches that can limit network access: port security and ACL. It's very simple. Port security verifies that only authorized devices plug into a switch, and ACL verifies that only authorized communication takes place for authorized devices. As usual, the devil is in detail. How exactly can we authenticate a device or a user? We could use credentials for verification, but that will require extra capability that OT devices usually do not have. So people usually end up using MAC addresses as device ID and maintain a database that either on network access server or locally on a switch. As for ACL, it acts like a simple firewall. It has less functionality, but also it has a very important advantage. ACL is a hardware-based filtering mechanism. That means that it doesn't affect bandwidth or latency. So we can argue that these features are more similar to built-in security on Ethernet switches, but I think it's important to highlight because in my experience, there are many asset owners who do have this functionality in their network devices, but simply do not enable it. Also, it is relatively simple to replace a switch in a working system comparing to upgrading a PLC, for example. So here is port security and ACL on our diagram. If done on a large scale, these features would require certain infrastructure to support centralized management of access policies, user device databases, and event logs. So keep this in mind when you are considering to deploy these features. Also, any security enhancement may cause inconvenience. Using the example of field device replacement procedure, if you don't have port security, you can simply swap an old device with a new one. But if there is a port security in place, you need to add the MAC address of the new device into the database first. So there would be an extra maintenance time to get this extra security. When it comes to secure infrastructure, the key topic is network segmentation. This concept is mentioned in all cybersecurity standards because it includes the very principle of dividing something big into smaller pieces to make it more manageable. Let's have a simple example. On this diagram, the OT system is large scale, and there are several subsystems that all connect to this supervisory level. If we refer to IEC 62443 terminology, To do network segmentation, we need to establish security zones. In this example, it makes sense to put each subsystem and control center into separate security zones. The actual definition of a security zone is a group of assets that share the same security requirements. Once we have zones, we will also have conduits between them, which are cross-zone communication channels. And the key component that we need to add into an OT system while performing segmentation would be a firewall. So let's get back to our simplified diagram. This is where we can put a firewall to perform network segmentation. The best practice is to perform whitelisting using a firewall, which means that we are allowing a limited list of only necessary communications and blocking everything else. And again, the more precise we can define proper communication, the better. Therefore, deep packet inspection of industrial protocols is one of the key features of OT-grade firewalls, apart from rugged hardware. Nowadays, firewalls, they embrace more and more additional functionalities that were originally separate protection measures. You may have heard the term NG firewall or next generation firewall, which simply means that apart from core stateful traffic inspection, the device has extra features such as network address translation, signature-based protection, and so on. And what makes network segmentation a bit difficult is the fact that in most cases we need to change IP addresses of OT system components. Because ideally every zone should have its dedicated address space, which requires reconfiguration of network parameters on end devices. Of course, alternatively, we can keep old addresses and use NAT to prevent overlapping, but this adds another level of complexity to the network. Actually, anyway, after segmentation, network thing I like to use for security is remote access. By remote access, I need any communication within or an OT system that is happening over a public network. It's controversial and cybersecurity people do not. The is so many when remote access has huge benefits or it is simply unavoidable. These scenarios arise, it has to be done quickly as possible. I'll give you a couple of scenarios for remote access. Anymore. So more and more asset owners, they rely on VPN connectivity on top of the internet. Of course, it has to be reliable and with some form of redundancy. When you use more than one ISP, and in addition, all the VPN gateways, they have to comply with field installation requirements. And the second scenario for remote access is an access to a particular asset. This could be required for technical support or IIoT applications when we need to collect data for analysis. The main challenge for this scenario is how to have minimum infrastructure investments and to keep it manageable and easy to use. We certainly don't want to punch a hole through all of our firewalls to take a connection from outside to certain devices. A popular choice is that the solution has, for example, a cellular internet access and usually cloud-based, so we can avoid the whole public-private It is important to note that if we are building an on-demand tunnel, there should be ways for the donor to control when remote systems are not. So here is notice on how I will spend more than remote work from home and applications such as this. My advice is to keep it visible. Whenever remote is established, the city should be it. And of course, all of the related risks have to be evaluated carefully and mitigated with a proper solution. And the last piece of the puzzle for field level OT security is threat detection. If we can get a copy of all network packets from OT, fit it into a powerful intrusion detection system that has deep packet inspection, machine learning, threat signatures, and information about devices, we can actually solve two problems. First, we can get notifications about potential attacks, so we can react accordingly. And second, we can also verify which devices are actually on our network transmitting. Network. In fact, most OT systems in production, they do not have up-to-date inventory. These kinds of solutions are very popular now. There are many companies that have an IDS tailored for OT. In fact, IDS is already included in many standards as an essential cybersecurity countermeasure. Here it is on our diagram. I would like to warn you, though, that there are several complications related to IDS implementation that may not be obvious at the first sight. It's actually not so easy to collect mirrored traffic. First, you need to have managed switches with mirroring capabilities. Second, you need to deliver the mirrored traffic to the IDS server. I heard some people put their hopes on remote mirroring features, also called RSPAN. But in my opinion, there is a very high risk of overwhelming the network with mirrored traffic and impacting original communications. So I think the best way is to build a separate network to deliver mirrored packets. Alternatively, you can limit the monitoring points to selected network junctions and give up trying to see everything. The most critical factor for IDS effectiveness is actually how the events are processed. Ideally, there should be a SIEM system which will correlate events from different devices into one logical series, and a team which will constantly monitor and respond to these events. As previously mentioned in the maturity model, IDS is kind of an advanced solution which requires more human resources to operate. Now that we covered solutions for OT cybersecurity, you can see how packed our topology became with protection. This is not a complete map of what's available on the market by any means, but I hope I covered the major things and I gave you a comprehensive overview of this topic. Implementing even part of this is definitely a great enhancement for OT cybersecurity. And to wrap this up, I would like to quickly share with you how MOXA product portfolio maps to this concept. We don't have endpoint protection, but we do have an industrial IPS that is called EtherCache, as well as transparent firewalls to protect OT assets such as PLC, HMI, RTU, ID, and so on. And our core business is still in industrial connectivity, so you can find a variety of Ethernet switches that have port security and ACL. We also have wireless infrastructure components and serial device servers with extra security features. To help build secure network infrastructure, we provide both next-generation firewalls with IPS functionality and routers with security features. We do have VPN gateways, including cellular versions and cloud-based remote access solutions. As of now, there is no OT IDS in our portfolio yet, but please feel free to ask us about networking solutions to support IDS deployment. We have experience integrating OT IDS with our network devices. And last, we do provide software to manage all of our products, which includes network management system with security posture assessment and a centralized device management tool. To get more details, you can check out our webinars, visit our website, www.moxa.com, or simply get in touch with our partner in your region. I think that wraps up our webinar for today. I would like to really thank you for your attention and hope to see you next time.
Okay, that was insightful presentation into cybersecurity on operation technology. I'll now pass the screen to David from MOXA to present MOXA's industrial cybersecurity products. David, you might need to unmute your mic, please.
Yeah, I'm so sorry. Can you hear me now? Give me a second. Hello, can you hear me now?
Yep, perfect.
Okay, cool. So this is David. I'm from MOXA FAE team. So right now, I'm going to introduce MOXA Industrial Cybersecurity Solution. As Sever just wrapped up, MOXA understands clients' challenge when it comes to secure their network and business. So from the bottom to top, from device protection to cybersecurity approach, MOXA offers a wide range of products. So from the device security, MOXA has an industrial next generation IPS, IDS, or even a to protect your critical asset with widest access control, DOS protection, and intrusion prevention function. For networking, MOXA EDS switch and wireless product can provide access control using port security and access control list, ACL. For security interface, MOXA next generation firewall with the EDR router and MRC, they offers functions such as DPI, packet filtering, data encryption, secure remote access, network segment, and so on. Okay, so the last one is the management network. So for security management, MOXA offers two management software. First one, we call it Security Dashboard Console, which we call it SDC, or Security View in MS View. The new Security Dashboard Console can manage the next generation IPS and also the firewall, so you can see what assets are linked to the device. The Security View in MS View can show you the security status of the device in networking, giving client an overview of security in their network. So here are the three MOXA industrial cybersecurity solution. From the left, as you can see, this is called Ether Cache. It's very tiny. The Ether Cache is industrial IPS IDS. In the middle is next generation firewall. It's also called IEF G9000. And then they can be managed by Security Dashboard Console, which is a security management software. So now I'm going to talk about the security function on those products. First, both of them do support the DPI. So what is a DPI? DPI stands for Deep Packet Inspection. When the packet goes into a DPI engine, it could recognize the device identification protocol function of that package and inspect it before it goes to the target device. The DPI technology means it can recognize both protocol and attack. It could also provide visibility of your network device by reading the vendor information in the package. It controls the flow of the package to protect your network. Most importantly, even with all those features and functions, the latency is less than 0.5 milliseconds. Okay, so here, this picture, we just want to do a comparison between the EtherCache IEC G102 versus the next generation firewall IEF G9000. As you can see from the left, the security feature, it has the IPS, IDS, it can do the DOS prevention, and it also has the firewall feature. So the firewall, the difference between those two is the firewall includes all of the feature of the IPS, but it also includes the networking, the routing, and so on. So here is also another comparison compared to our next generation firewall and security router. What's different between them? Start from the left, security router. What you can do is you can set a lot of firewall policy. So such as you can inspect the protocol and so on. But the thing is, this thing has to set in menu, but you won't be able to protect the virus, malware attack, and antivirus. So what this does is the next generation firewall, you can also configure your firewall policy, and also you have the IPS feature. So this feature is basically enabled automatically. So what it can do is it can block the virus, block the attack, block the DOS attack. Okay, so now we're going to talk about the malware blocking. MOXA's industrial IPS and next generation firewall not only perform a whitelisting control, but they can also block and contain the spread of the malware. So as you can see from this diagram, one of them, if you have the firewall within this zone, it will block it to go to another one. All you need to know is to place a MOXA industrial IPS in front of the critical asset can protect that from critical asset against to cyber threat coming from the network. And it can also prevent the malware from going into other network. Moreover, it's bi-directional gateway that can prevent the spread of the malware within your network. So that's the diagram you can refer to. The next thing is virtual patch. As Sever mentioned in the video, in his webinar, he said about he mentioned about sometimes it's hard to patch every product. So that's why there's a concept of the virtual patch. The key feature of the MOXA industrial IPS and next generation firewall is virtual patch. MOXA understand that in the reality it might be hard to implement all the patch to all the device. So instead of the directly patch to the device, you can put MOXA industrial IPS in front of the device that you're trying to protect, and then it will do rest of it. So the last item I'm going to highlight here is the DPI protocol filtering. With the DPI technology on MOXA's IPS or next generation firewall can perform a detailing whitelisting control, and access control can be done at the device level, server port level, and protocol port level, and so on. With this level of security, it can lower down the risk of the cyber threat. So once we know all the functions, the last thing we're going to talk about is the security management platform. After we talk about the industrial IPS and next generation firewall, let's take a look of the management software, Security Dashboard Console, SDC. Basically, SDC is used to configure, monitor, set policy rule, and update signature to most industrial IPS or next generation firewall, which is deployed in multiple places. It has a network traffic analyzer that can provide a device visibility and can alarm and log cybersecurity event. What's more is it can easily integrate with SOC or SIEM. So once we talk so much about the IPS, the next generation firewall, now it comes to configuration. Is the configuration very hard in order to do that? No, it's actually pretty easy. For the IPS, all you need to do is just enable or disable the feature, and then it will take care of the rest of it. And then remember the firewall, the next generation firewall, it also does the same for the IPS, but it also provides you a place to set the firewall policy. So that would be the screen that you can look at. So last one is a deployment. So where can we put all those products? For example, where to place the IECG 102, the IPS deployment. Basically, if there's important asset such as HMI, the SCADA, the PLC, then you can put the EtherCache in front of it to protect your important asset and also to provide the virtual patch and DPI like what I mentioned earlier. However, for the firewall, since it's firewall, so what you can do is you can use as a zone. Use this firewall to connect to a zone. And within this zone will also be protected as well. So in summary, what I'm just going to highlight in the summary. In summary, we have the EtherCache. This is basically you place in front of the mission critical asset, and it provides the bidirectional protection. Not a single way, it's bidirectional. And then you can help user to visibility of their protection and network. So here will be the EtherFire. EtherFire is a next generation firewall. So instead, it provides you the network segment. So basically, you will cover industrial IPS ideas, everything, and then also include the networking, the routing part as well. So the last product that I'm going to highlight here is the SDC function. As you can see here, this is a centralized management. So within this management, you can see you can monitor all the IPS, all the firewall, and then you can also configure them as well. So you have the visibility of all the device and the status. And another thing is it also provides you the log analysis. So which means you can save those logs to SOC or SIEM for the analysis and later on. So here is my product sharing. If you had any question, feel free to ask. Thank you.
Okay, thank you, David, for the product sharing. To demonstrate how the IPS unit can handle external cyber attacks, I will be using a common vulnerability exploit to attack Kevin's workstation. So right now, Kevin will now explain the scenarios that we have set up.
Hey, good afternoon, everyone. My name is Kevin from APulsar Technology. And for the demo of the IPS, we will be showing two scenarios. The first scenario is, as you can see at the top part, it shows, hold on. Okay, it's just a simple test that we are going to do. This attacker PC is Weyau's PC and connected to the LAN network to a switch and will be attacking a VM machine in my PC. Okay, so the first test should be successful because we have not connected the IPS. And the second scenario, we will connect the IPS in front of the PC. So we will test the second attack and see if the IPS did deny the exploit attack. Okay, so now we will test the scenario.
Okay, so the first scenario involves me infiltrating Kevin's laptop, the virtual Windows 7 machine with a Kali Linux exploit. So I will be using a CVE 2012 exploit, which is a Windows 7 common vulnerability exploit. So the way someone would exploit this is to set an IP address of the host, which is Kevin's IP address. And it is 191. So once you have set it, all I've got to do is to hit exploit. So now I'll be, we'll move the screen over to Kevin's screen so you could see the exploit work. Right. So this is his Windows 7 working, and this is the blue screen. So as you can see, it's a very effective, instantly kills his OS. So he will now reset his OS and connect it to an IPS unit, which might cause him to disconnect for a bit, but he will be right back. Okay, so he's back. All right, so now that he has set up his IPS, he's gonna demonstrate the interface.
Okay, good afternoon everyone. Okay, I will take control now. Okay, so the first test, as you can see, it was successful. Wei Yao was able to attack my PC, and my PC is down by the blue screen of death. Okay, now I have connected my PC to the IPS to show you that. Hold on. Okay, this is the IPS interface, the etcatch interface. This is the web UI. Okay, so once I've connected my device to the IPS, you can see in this visibility, asset view, and you can see there's two PC here. One, this is my physical computer. I will show you my IP address. As you can see, 117. This is my physical IP address, my physical PC IP address. And this is my virtual PC, the one that Wei Yao attacked recently. So, as you can see, 191. So this two PC is currently under the protection of the IPS. Okay, so please ignore this, as this was a test run we did at 11:40 AM. So we will be doing the same attack as previously, but now my PC is connected to the IPS.
Okay, now right back to me now. We're gonna do the exact same thing. I'm gonna use the exact same exploit as you've seen, and the target has been set to Kevin's virtual PC with IP address ending in 191. So I'm gonna use the exploit right now, and Kevin should share his screen so you could see that his machine survives this exploit. As you can see on the Linux console that the exploit failed to attack.
As you can see, my PC currently is still up and running, even though Wei Yao has sent the payload. And to prove that, that the IPS detected the attack. It refreshed, and as you can see, currently now at 3:05 p.m. 15:04 today, it detect an exploit attack by Wei Yao's PC. As you can see, it deny the traffic, the attack. So it shows that the IPS was able to detect the exploit, and my Windows 7 PC is safe. Okay, so that is the end of the demo. But before that, I will show you one of the important software in maintaining this IPS. It's called SDC. Okay, this SDC is a security dashboard console to manage all your attack catch or IPS devices. For example, if you have 4 or 5 or 10 IPS, it's an easy way for you to manage all of them. You can easily update your firmware, and it's also okay, as you can see, all the configuration that you configure in this SDC, bear in mind that it will override all your IPS configuration. So if let's say you have 5 IPS, you just need to manage it here. You don't need to manage it in the IPS web UI. You can just manage all your devices here. As you can see, you can enable intrusion prevention system, or and then I forgot to mention that previously this is the security prevention that we have enabled to deny Wei Yao's attack. I've enabled intrusion prevention, prevent and lock, denial of service prevention, prevent and lock. Okay, if you do prevent and lock, it will deny the traffic and log it. If you do monitor, it will just only detect it, but the traffic will still go through. So to block, it is advisable to put it on prevent and lock. Okay, so another key features is in the IEC for the logs, you can't export it. You can just see it in the SDC. There's an option for you to export the logs. So if you say you have a lot of logs, you want to export it for audit purposes or for any security purposes, you can export it. So there's a lot of features in this SDC. As you can see, there's EtherCache and EtherFire. This SDC is software for you to manage IPS, and one of the upcoming devices from MOXA, it's called Next Generation Firewall. So currently, we are demonstrating the IPS. The Next Generation Firewall is still not available, so we will only mention about IPS, but this device can manage both of the device, the Next Generation Firewall that will be coming soon, and the IPS. So yeah, that's about it for the demo. If you have any question, oh yeah, and sorry, and this dashboard, it's also an interactive dashboard, so you can see all the live update of any attacks in terms of event categories, cybersecurity, severity, policy enforcement. You can customize the widget based on what you want to see on the dashboard. Just enable and click add. Whatever you want to be shown on the dashboard, you can add it here. Okay, so that's about it. If you have any questions, please feel free to ask, and all of us will be happy to answer your question. Thank you.
Okay, so that concludes our presentation. We'll now take all questions listed on the Q&A, and we'll try to answer them to our best abilities. So if you have any questions throughout the presentation, this is your chance to ask them now. We have professionals here with us, and they're ready to take your questions. So if anyone has any question at all throughout the presentation regarding perhaps the product or the IPS itself, the functions, the features, or if you have any more specific questions, please feel free to email them directly to eddy.chew@apulsar.com.my, and we'll be happy to get back to you directly. But right now is your chance to ask the very difficult questions, because we have Sever here who is a cybersecurity professional, and he's ready to help. But if no one has any more questions, we will be ending this session in about 5 minutes. Or if you'd like to start the discussion, we'll be happy to do that as well. Okay. Well, once again, thank you all for attending our webinar. Hope you guys have a very nice day, but please feel free to ask. We'll be here for another 5 minutes. Okay, this is the final minute to ask your questions, if you have any. If you would like to know more about how we hacked into a Kevin system, you may ask that too. It's pretty interesting that hacking is getting easier and easier nowadays. So it's important to have a reliable IPS unit to prevent operational technology from failing. Okay, so it's 3:15. I think that we should end our presentation. Thank you guys once again for attending. Thank you, David and Sever from MOXA. Thank you, FMM, for hosting this. Hope everybody have a wonderful day. Thank you once again. So we shall end the meeting right here.
Thank you.
Thank you.